Chapter 7, Number 2. A pendulum bob swings from point 2 to point 3 along the circular arc indicated in the figure, from there to there. Is the work done by the bob on the bob by gravity positive, negative, or 0, and explain? And then is the work done on the bob by the string positive, negative, or 0, and explain? Just to be clear, the pendulum is a device consisting of something that can swing, and in this case what's called a bob, which is just an old style word for the thing at the end of the string. And we're assuming that essentially the string here, since we don't know anything else, we assume the string is ideal and massless. So everything's concentrated right here. That's not relevant for this problem, but we'll be dealing with pendulums quite a bit. Alright, so is the work done on the bob by gravity during that path positive, negative, or 0? So what we're going to do is we're going to say along that path, which is an arc of a circle, something like that. We know it's a circle because the string can't change its length, so it's always the same distance from the pivot point. So this length is always the same, so that's arc of a circle. And we have the bob at some point along that path. And at the moment, that means that the pendulum is swinging, or the bob is swinging tangent to the path. So I'm going to draw that like this and say that's the velocity, that's the path taking at that moment. And we have at that moment gravity, which defines downward. And we have a tension which points along the string and therefore is radially inward. And that's going to be very significant later on. So in part A, the work done by gravity is going to be negative, because if we consider gravity sort of consist of two components, Fg perpendicular and Fg parallel along the motion, we can see that the gravity is tending to pull backward on the bob compared to the original motion. The bob moves upward, gravity pulls against that, and therefore the work done by gravity is negative, since it's opposed to the actual motion. Part B, well, we see that the force of tension is perpendicular to the displacement. Since the displacement is along the tangent of the circle, and the tension is by definition sort of radially inward. And therefore, this implies that the work done by the tension is equal to 0 at all moments. No matter what part of the arc you pick, the tension will do no work during that arc. In the essence, the tension is not accelerating or is not speeding up or slowing down the bob, it's only changing the direction of its motion. Gravity, on the other hand, is going to slow it or speed it up. There is no part C, but we can sort of use a fictitious part C to sort of reinforce these answers, or to talk about A a little bit more. And in that I'm going to say that part C at S, this mythical part C up here that I'm going to create, what is the total work done? And that's easy enough. The total work is going to be the sum of the work by all forces, so it's the work due to gravity plus the work due to tension, but we just said the work due to tension is 0, so it turns out to be just the work done by gravity. On the other hand, the work energy theorem tells us that the total work is also delta K, and delta K is negative, because the object starts with some speed here, and it has less speed up there. So it's a lesser number minus a larger number, so delta K is negative, but delta K is equal to total work, and total work is equal to gravity, so this sort of confirms that our answer in A, the work done by gravity, would have to be negative in this case.